Going to get into intermolecular forces. This is an intermolecular force is a force between two or more molecules. So if you have a molecule like so and another molecule like so, there's going to be some sort of force that is going to be pulling on, where they're going to be pulling on or attracted to one another. All molecules have some sort of force. Some of them are stronger, some of them are weaker, but there will be some sort of force. So there's really three major forces that we're going to talk about, and that would be London forces, that would also be dipole-dipole forces, and then also hydrogen bonding. So for London forces, first of all, London forces are the weakest of all of the intermolecular forces, and they're produced by what we call an instantaneous dipole. Instantaneous dipole. Everything has London forces. Every molecule in the universe has London forces, or can create London forces between itself and another molecule. So whether it's polar, whether it's non-polar, anything like that, it will have London forces. Some things, that's the only thing that they have. So like non-polar substances, the only force that they have would be London forces. Okay. Now, how do London forces work? So say we have a molecule like so, and we have another molecule right next to it. Well, there's electrons in this bond. There's electrons all over the molecule, and they're constantly in movement. They're constantly moving around. They're in motion, complete random motion. But let's say for a split second, for an instant, all of the, or a majority of the electrons end up over on this side, for instance. If that's the case, then this is going to have a partial negative side. You see the little partial sign were to be partially negative for an instant, and this side would be partially positive for an instant. Okay, and if that's the case, if this if this molecule that's right next to it is then influenced by it, this side is partially positive. What's going to happen is all the electrons, or a lot of the electrons, are going to be attracted to this partially positive side. So you then have this side being negative, because there's more electrons over there, and this side being positive. And then what's going to happen is there's going to be an attraction here. And then if there's another molecule next to this one, the same thing would happen, and you see there's a pattern that happens, that exists, where it's like a chain reaction. Now this dispersion force that occurs does not last very long. Okay, it's a very weak force, does not last very long, and eventually it goes away. Okay, but there are some forces. There still is a little bit of force that happens there. Okay. Again, all compounds, all molecules have London forces. Okay. Now, dipole-dipole. A dipole-dipole force is kind of like the middle of the three forces that we're going to talk about today. It only occurs when you have polar molecules. Okay. It only occurs when you have polar molecules. And what happens is, kind of like with a London force, we have these dipoles that are created. In a polar molecule, those dipoles just kind of always exist, right? So if we have let's say we have a trigonal pyramid shape where this side is partially negative, these sides are partially positive. Okay, and then if we had another one of these molecules right next to it, the positive side from one molecule is going to be attracted to the negative side of another molecule. And that attraction that forms is considered dipole, or are considered dipole forces. Okay, so a polar molecule would have dipole forces and London forces. Okay, the stronger would be dipole. So if a question was to ask you, what is the strongest intermolecular force a particular molecule has, if it's polar, it would be dipole. Okay, our final intermolecular force that we're going to talk about would be hydrogen bonding. And hydrogen bonding is the strongest type of intermolecular force. It's so strong that we give it a name that's called bonding. It's not a true bond, it's actually an intermolecular force, but it's so strong that it kind of almost appears like a bond. So what you need is a polar molecule, and you have to have H, a hydrogen, bonded to a very highly electronegative element. Okay, and those highly electronegative elements are N, O, or F. Okay, and what happens there is, for instance, if we have NH3, if we have ammonia, nitrogen is so electronegative compared to hydrogen. Hydrogen is very low electronegativity. Nitrogen is very high. So those electrons that are being shared in these bonds are almost being pulled away from the hydrogen by nitrogen. And so the dipole moment here is very large. So we have a huge negative, okay, and we have a very large positive, okay, and so there's going to be strong attraction between one molecule of ammonia to the next, because this is almost like an ionic bond, because that nitrogen or the oxygen or the fluorine are pulling so hard on those electrons that they're almost taking them away from the hydrogen. And so that attraction then that forms is considered a hydrogen bond. So you have to, when you're looking to see if hydrogen bonding exists, it's not just that it has hydrogen. The hydrogen has to be bonded to N, O, or F. Okay? Even if these are present, if they're not bonded to H, then it can't be hydrogen bonding. Okay? All right. I hope this helps. Let me know if you have any questions.